here's our video for rotated conics. I'm just going to go over a few things before we start. At the top, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0 is the general form for conics. Usually the b term is 0, so they're not rotated. But when it's not a 0, you know that it's rotated. When you find the determinant for each equation you're given, when it's less than 0, it's an ellipse. It also could be a circle, but you can't rotate a circle, so don't bother. When it equals 0, it's a parabola, and when it's greater than 0, it's a hyperbola. Back up at the top, cotangent of 2 theta equals a minus c over b, or you could consider it tangent of 2 theta equals b over a minus c. The first thing you need to find theta. So that's your angle of rotation. So you can draw your primed axes and find your primed form of x and y. The next thing here is the different equations you need to find the prime forms of x and y. X equals x prime cosine of theta minus y prime sine of theta, and y equals x prime sine of theta plus y prime cosine of theta. After you plug in the cosine and sine for theta and simplify, you have the primed forms of x and y that you plug back into your original equation.
This is our first equation. First we need to find out whether if it's an ellipse, hyperbola, or a parabola. So you would have to do b squared minus 4ac. This would be our b, this would be our a, and this would be our c. So we would do negative 6 square root 3 squared minus 4 times 7 times 13. This would give us a negative number, which is less than 1, so we know that it's an ellipse. Then we need to find the angle of rotation, which is tan 2 theta, which is equal to b over a minus c. And like I said before, this is b, this is a, and this is c. So we just have to do that. So negative 6 square root of 3 over 7 minus 13. That would give us square root of 3. So we know that 2 sine of theta, using our trig, we would know that is equal to 60 degrees, or theta would equal to 30 degrees. That would be our angle of rotation. Then we need to find what x and y is equal to by doing x is equal to x primed of cosine 30 degrees minus y primed sine of 30 degrees. Simplifying that would get us x prime square root 3 minus y primed over 2. And then you would find y by doing y is equal to x primed sine of 30 degrees plus y primed of cosine 30 degrees. And that would equal to x primed plus y primed to square root 3 over 2. And then what we want to do is take these two, x and y's, and plug it into the original equation. So we would have to do 7 times x prime to square root 3 minus y over 2 squared. And just plug in all the x and y's for this equation. And I'm just going to move the 16 over to the other side. Once you have that, and then you would have to FOIL this whole equation out, but that's going to take a long time, so I'll just go into the simplified version. So you would end up with 4x prime squared plus 16 y primed squared is equal to 16. If we divide the whole thing by 16, we would get x prime squared over 4 plus y prime squared over 1 is equal to 1. So that would help us get us the key information for our primed graph. We know that the center would be at 0, 0. Our vertices would be at 2, 0 and negative 2, 0, since a squared is equal to 4. Our co-vertices would be 0, 1 and 0, negative 1, because our b squared is 1. And our foci would be square root 3, 0, and negative square root 3, 0, because c squared is equal to a squared minus b squared. So just plugging that in would be 4 minus 1 is equal to 3. So c is equal to square root 3. And then we would have to graph it. So this is our regular x and y coordinate graph. So our primed graph is rotated 30 degrees. Based on the given information, we can just, so this is our center. Our vertices would have to be on, so this is our first vertice, and then this is our other vertice. And then our co-vertices would be here and over here. That gives us our ellipse shape, and then our foci would be around here. These are the primed coordinates, but we would have to find the actual x and y coordinates for the vertices and the co-vertices. So what we'd have to do is plug our values back into this equation over here to get our actual x and y's. So x would be equal, or this is our vertices. So x is equal to plus or minus 2 square root 3 minus 0 over 2. So x would equal to plus or minus square root 3. Y is equal to plus or minus 2 plus 0 square root 3 over 2. So y is equal to plus or minus 1. So this is our actual coordinates for our vertices, and then our co-vertices would be x is equal to 0 square root 3 plus or minus 1 over 2, which is equal to plus or minus 1/2. Y is equal to 0 plus or minus 1 square root 3 over 2, which gets us plus or minus square root 3 over 2. So then our co-vertices would be plus or minus 1/2 plus or minus square root 3 over 2.
This is another example of a conic that can be rotated, and to find out what kind of conic it is, first we use the discriminant. So formula is b squared minus 4ac, and we plug in our values. So in this case, negative 2 root 3 is b, 3 is a, and 1 is c. So that comes out to 12 minus 12, which is 0. So it's a parabola. Okay, and then to find the angle of rotation, we use our formula and plug in our values. So b over a minus c. That is negative 2 root 3 over 3 minus 1, which simplifies to negative root 3. And then using unit circle, we know that that's 2 pi over 3. And so our angle of rotation is pi over 3, or 60 degrees. So to find out what we're going to plug in for x and y, we can use a formula. X equals x prime cosine theta minus y prime sine theta. So if we plug in cosine of pi over 3 would be 1/2, and the sine of pi over 3 would be root 3 over 2. We simplify, we get x prime minus root 3 y prime all over 2. And then that's our x value. For y, it's pretty much the same thing. Use the formula x prime sine pi, or sine of theta, plus y prime cosine of theta. Plug in. And simplified, you get root 3 of x prime plus y prime all over 2. And then you have your x and y values. Now it's time for our favorite step, which is actually plugging it in and foiling it. I'm going to plug in my x and y values. Okay. Having distributed everything, our final equation is x equals negative y squared in the prime form, because pretty much everything cancels except for the y squareds and the x's. Since the equation was x prime equals negative y prime squared, the center, or the vertex, because parabolas don't have centers, would be at the origin, 0, 0. To find the focus, you would look at this, which would, the negative 1, which equals 1 over 4p, comes out to p equaling negative 1/4. From this, you can determine that it's a horizontal parabola. The focus in the prime form would be at negative 1/4, 0. So you would also want to point out that in the correct notation, this would be the prime version, not necessarily the rectangular version. First, you have the regular x, y plane, and then based on your angle of rotation, which in this case is pi over 3, you're going to draw the x prime and y prime axes. So this right here is pi over 3 radians. And then to graph, because it's a parabola, you have the center at 0, 0. And you also have a focus, which is at negative 1/4, 0. So like right about here. That's our focus. And then because it's a parabola, you also want to plug in some points so you know how the curve is. So I plugged in for y, because it's a horizontal parabola, these points, and so the graph would end up looking somewhat like this. one more thing that I forgot to mention is finding the directrix. So obviously you already have P, and the directrix would just be, in this case, x equals 1, 4. So this is your prime directrix right here. Yeah. Okay, so one last thing is finding the rectangular form of any of these points. So in this case, since the vertex is just 0, 0, it's going to be the same in the rectangular form. So I'll do an example with the focus. So to find the rectangular form, basically you just plug in the x prime and y prime back into your original x and y equations, and then that'll give you the rectangular form. Okay, so having done out the work, our rectangular x value is -1/8, and our y value is -√3/8. So the focus in the rectangular form would be -1/8 over -√3/8. And that's pretty much the end of what we have to cover for conic rotations, and I hope you enjoyed this video. So see ya, and have a great day.